Welcome to Unreal Engine sample project. My name is Cliff, and today I will go through AI with Behavior Tree and Blackboard. There are a couple of methods to implement artificial intelligence in Unreal Engine. Using Behavior Tree and Blackboard is one of them. So, I will use a sample project to explain and practice implementation of Behavior Tree and Blackboard. To use AI, you must know basic blueprint programming skills with Unreal Engine and also have knowledge of using events and event dispatchers. It's very important. By end of this video, you will be able to develop AI scenarios by using Behavior Tree and Blackboard, and also you will learn how to use AI components and modules to implement complexities within your AI character or object. Sometimes AI is not just making enemy units or friendly units. Sometimes you may, based on the scenario of your game or application, you need to make an object intelligence, like weather. The weather must change based on player character action behaviors or enemy units behaviors or friendly units behaviors or all of them together. So the Unreal Engine gives you tools to implement such a scenario with your application or game. So please download the sample project, run it, make sure it works on your system very well, shaders rendered, everything ready to go, and you can download it from this link, which will be this guy here. And in this video, I will go through a real example of behavior and knowledge. I will go through the sample project, hold the video, we will use that sample project, so make sure it works fine. And I will talk about a sequence type of behavior with AI task and service. I will talk about a selective behavior, and we'll go through AI decorators. And also I talk about a simple parallel behavior. The sequence and select and simple parallel are basically known as AI composites. And at the moment, end of 2024, these are the three main behaviors that you can implement with Behavior Tree and Blackboard. At the end, we go through a homework, or let's say practice, just to make sure you can implement scenarios, AI scenarios based on a real-world example. Imagine we have an office, and suddenly, because of electricity problem, gas problem, everything goes on fire. Fire is everywhere. All right. As you know, every office there is an emergency exit. Inside in every office, we have an emergency exit. There's a door, there is a path that if something happens, something goes wrong, people can use it and evacuate the office. Now, we have three characters here. The first character is a visitor. Second character perhaps is another visitor or someone who works in the office, and the last character is a kid. And they are in the office. Suddenly, fire comes up, and all of them know the location of the emergency exit. So this is part of their knowledge. This guy knows where is it. This guy already knows, and the kid, he knows his mom and dad told him, hey, if something happened, this is the happened, this is the exit door, just run there, blah blah. Anyway, the first character, he is a gentleman. He will check if there is a kid, there are ladies, there are elders around. He will go to them, you know, hey, can I help? I know where is the exit door, let's go together. The second character only think to himself. So it doesn't matter what's going on around. He just run to the emergency door, to the exit door. And the third character, Kid, is frightened. He knows where is that door, but he can't move. Crying hard, very frightened. So perhaps one of these guys can find this kid, and together they can move to emergency door. So the first character has a behavior. He helps everyone and then move to that location. The second character has a different behavior. He is frightened. It doesn't matter who is around, what is going on. I need to save my life. That's a behavior. And the third character, it is a behavior. He knows where he need to go, but he's frightened. So when we talk about knowledge, all of them have the knowledge of that door. They know where is it. All of them know the position of that door. The knowledge in Unreal Engine will implement it in something called Blackboard. So when you want to implement the knowledge of your AI characters, you need to use an object called Blackboard. If you right click and go to the artificial intelligence, choose Blackboard object. I call it bb_00. And if you open, you will find you have number of data types to implement a Blackboard key, or let's say Blackboard variable, and make that knowledge part of your AI character. You may surprise, oh my god, what is going on? Just be patient. I will go step by step how you need to think and implement AI behavior tree and Blackboard. So far, the knowledge need to go to Blackboard. In this case, I can make a vector because the location of this door is it's just a X, Y, and Z location inside the map. So I make it like exit door location. Perfect. Now, to implement the behavior of each of these characters, you need to use something called behavior tree. So if I open the project, go here, right click, artificial intelligence, behavior tree, bt_00. And when you make it, you must assign the knowledge you make to this behavior tree. So each of these AI characters, yes, they know where is it and they have their own behavior. These two need to be linked together. So when you make behavior tree, go to the behavior tree part and choose your Blackboard to 0, 0. Compile and save. Perfect. Save all. Now, we need something to use this knowledge and behavior. The object who use these two and implement the artificial intelligence actions inside your game is known as AI controller. The AI controller is responsible to use behavior tree and Blackboard and make basically presents the intelligence inside your application or game. So you need to right click, go to blueprint class, type AI controller, and here we go, we have AI controller here. Choose it and select it. I say BP_AIC stands for AI controller _00. You can use a different name. And here we go. When you open AI controller, like any actor blueprint, you have begin play and you have tick. Perfect. So the question is, yes, we make a controller. The AI controller will use the behavior tree and Blackboard, which I will point out soon. Just be patient. Now, how about the character? This character has graphics, has animation, has sounds. How this character need to use behavior tree and Blackboard and AI controller as well. So, a very, very simple to make a prototype of an AI character is just using your main character. In this sample project, I use a third person character, so I can use that for my AI characters. You can use first person, or you can make your own character, doesn't matter. So I just duplicate it. I call it BP underscore AI char underscore 00. Perfect. So when I open it now, because this is a copy of third person character, as you see at begin play, I grab the controller and cast, that's by default actually, and cast it to player controller. So whatever player do will go through enhance input local player subsystem, and from there it grab the mapping and it does the job. So when I run the game, I can move up and down, jump and all those things. Perfect. We don't need this, all of them, because this character will be controlled by AI controller. The character has an AI controller. AI controller will use behavior tree and Blackboard and control our character. So what we need to do is we just need to get rid of all of this code, because these are designed for player controller, player controller. And all you need to do is just go to the root, type AI controller. Here we go. And change your AI controller from default to AI controller 00, which we already made. Compile and save. Perhaps you need to remove the follow camera, because these are for third person character controlled by player. Or if you want to switch to this camera because of the game scenario, for example, you want to detect there is a scenario player can see from AI view, something like this, you can save it and use it for that purpose. But overall, we don't need that. So let's get rid of these guys and compile and save. And here we go. So this AI character will be controlled by AI controller 00, and AI controller 00 will use Blackboard and behavior tree. How it use behavior tree, I will point out soon. This is how you set up your AI character. So perhaps in case of copy and change the third person character or first person character, you want to do something different. Having your own character and all those stuff. So with this introduction, let's see what we have. So let's run the project. I have 4 different AI character here. This is number 1. As you see, just move to a target. That is number 2. Just go through 3 different targets. And this is number 4. It was yellow before, as you see, suddenly became black. And there is a reason behind that. And we have also another character which moved between 3 different locations and is very fast. So how these things, or how they know where they need to go. Remember, we have example, we have knowledge, these characters knows where is it, and this guy just moved straight away there, and so how these characters know where they need to go, what need to be done. For example, if I move to this alarm trigger, straight away that character will chasing me and then return to his own, which is very useful to implement an AI behavior for an enemy units. Anyway, so let's see how things is done here. Same method which I explained. I already make my AI character number 1. This AI character number 1, let me just remove this behavior trees and AI character. This AI character number 1 has AI controller 0, 1. So let's open the AI controller 0, 1, which is this one here. Perfect. So at begin play, inside AI controller, I am running my behavior tree, and then I use the blackboard. Keep in mind, blackboard represent the knowledge of this AI character, and behavior tree will run the behavior. So I make a literal name and I call it position underscore target 0, 1, and I set the blackboard value as a vector of this key name to this vector value. At the same time, I can get that blackboard value and just draw a debug box. So this is how you set and get the knowledge from your blackboard. In this case, blackboard 0, 1. So let me just open blackboard 0, 1 and see what we have there. Yes, we have position target 0, 1, and we have another position target which is called position target 0, 2. Both of them are vector. Keep in mind you can assign many type of knowledge in your blackboard, like a string. It can be an integer, it can be an enum, even boolean. Anyway, perfect. So how that works, let me just run one more time. So it sounds like after a delay, this object start moving toward this destination, this guy here. So how that works? So that is a behavior. These guys have different behavior. That one have different behavior, and this one behavior is very simple. Just move toward the position, to destination. Very similar to like this guy here. Okay, so let's open the behavior tree. As you see, the behavior tree has a root. If I open the first behavior tree, which I already made, the behavior tree, when you make it, an empty behavior tree has a root. And from there, you can assign a selector, a sequence, or a simple parallel AI composites. These are main type of behaviors which you can implement within your AI. I will go through more details, just be patient. So for my behavior tree, which is behavior tree 0, 1 for the AI character 0, 1, this guy here, I use a sequence. So grab this guy and I choose a sequence like this. Perfect. From that sequence, just you can click and drag, and that when you leave the mouse it gives you the selection you want. From that sequence I am using something called AI task, and it is a weight like this. And after that I'm using something called move to AI task like this. The wait AI task has a wait time. Let me just bring it to like this. The wait AI task has a wait time which is 2.4. So if I run it after 2.4 seconds, this guy start moving like this. And the second task is move to. The move to task can be implemented with a blackboard key. In this case, I say go to position target 0, 1. I can say go to position target 0, 2. And if I run it, nothing is happening. You may surprise, okay, why nothing is happening? Because if I go to AI controller, I only set position number 1. I didn't set position number 2. So if I set position number 2, basically I set the knowledge to I implement the knowledge of a position for the blackboard key number 2, then it will move to that position. Oh, what happened? Oh yes, I need to use this blackboard. Here we go, compile and save and run. And now it start moving to the other position, which is that guy here. Is that true? Let me double check. X, Y, Z, if I go to the map, and this guy here has X, Y, Z, same position. So how that happened? Basically based on this sequence, things are happening. You may confuse, okay, what do you mean? Let me just grab this behavior. Please do that with me at the same time. If you have another monitor, grab your behavior tree and put that on the second monitor. That's way much easier to track what's going on. Grab this guy here, move it up to here. Perfect. Now I back to the editor and resize the editor if you use one monitor in a way that you can see everything. Perfect. Now grab this one a little bit here, much better. Now I need you to run the application. You have your behavior tree separate monitor, or like this, run the behavior tree, and as you see it, and then you need to choose AIC01 if it's not selected. Let me run one more time. So as you see from here, it sounds like the wait task is running and then it switched to move task. This is how a sequence composite is working. It will start from left to right. This is number 1, this is number 2, and this is number 0. So the sequence grabs 0, run the sequence from left to right. First it's waiting and then it moves to the target. And then it will return to wait and try to move to again. Because it is on the same location, you won't see anything. And this sequence is running and running and running forever. So if I change this wait time, let's just make something else. Let's grab this root, put that here. I have a sequence of wait for 2.4. First I go to target 01, then I wait for 5 seconds, and then I move to target 02. This is number 1, number 2, number 3, and number 4. And I have a sequence. So if I run it, it's waiting. As you see, it's waiting here. Then it's moved to target 01, which is this one here. And after that, it should wait for 5 seconds. See, it's active, it's waiting 5 seconds, and then it moves to next target, which is that guy there. So this is how a sequence behavior, sequence composite, dictate the tasks to get executed one after each other. And when it reaches to the end, it will repeat again. So as you see, it goes here, target number 2, it will return to the beginning of the sequence, which is this guy here, wait for 2.4, and then move to target 1, like this. Very, very simple patrol behavior for enemy units, perhaps, if you want to. And another very, very important thing from this monitoring, visual monitoring system you have is your blackboard values. I can see my blackboard values here. So now let's back to behavior tree and get rid of implementation of the second point. Compile and save. Sorry, back to AI controller. I said behavior tree, my bad. So here we go. If I run it, so the second one is invalid. As you see, it doesn't have any value. So let's see how that works. It goes to the first one, wait for 5 seconds, and try to move to an invalid target. It can't. It will switch to the first one, and then second one, which is already there. Wait for 5 seconds, try to move to the next one. It can't. Wait again, So and if I stop it, nothing is going wrong. You don't have error message. That's very important. You even don't have any warning here. So be careful when something like this happens and your AI behaves strange. Perhaps your behavior, your Blackboard is invalid, whatever you have. Perhaps this value is not set. And nothing goes wrong. Well, sometimes you may experience crash because of the complexity of behavior, because the Blackboard key is, perhaps, but normally you won't get anything. You won't get any message of why this is not working. So be careful. Perfect. So let's just review. Yes, we figured out how behavior tree and Blackboard are connected to each other. Blackboard is knowledge. Behavior tree is behavior. AI controller will run behavior tree and Blackboard. And AI character will follow AI controller to behave in exactly same that a behavior tree dictates to the character. So let's back to AI controller and disable begin play. And back to the AI character and connect the begin play event to this part. So here I get controller, cast it to AI controller. This is how you get AI controller. Or you can say self, get AI controller. How to get self, get a reference to self, this like this guy here. Self means this character. And from here you can cast to AI controller. And from there, I just call an event. And I send the move location to that event. This move location is a public variable. I can set it to anything. So in this case, I just set that. Let me find it. It should be, here we go. It is this location, and that is basically this guy here. Go up, this one. So same location, I just implement to this guy. Right click, copy back here. Location number 1. Right click and paste. Same location. So, and also I have a position target. This is my Blackboard key name. Let's change it to, for example, number 1. And the second location is basically this one. I believe that should be this one here. Double check. Yes, that's the same one. Alrighty. So what I do at begin play, I ask the AI character, I ask the AI controller to move to that location. So that's what's happening. I grab the Blackboard. From Blackboard, I grab this position, set target position 01 for this event. As you see here, I didn't pass any name. For the second one, I did anyway. And draw the box and print a message. Perfect. Compile and save. And if I run it, nothing will happen. I have the message. The Blackboard is set. Behavior tree. Okay, it's not here. I will tell you. So nothing is happening. Why? Because the behavior tree is not running. As you see, there is no owner for that behavior tree. And even though the Blackboard values is not set, we don't know the owner. If you don't know the owner, then there is no attachment between these two. So whatever you set is just set for the object, not for the actual game object. So what is going on? So every time you want to use a Blackboard, you need to run the behavior tree. If you don't run the behavior tree, nothing will run. No behavior will be presented in your game. So this is very, very important. Now if I run it, it will start moving, and the behavior tree is running, and the target is already set. So very, very important if you experience unusual behavior when you try to call your AI, when you try to activate your AI, keep in mind the behavior tree need to get executed first. So it's better I have my begin play, and from this begin play I run my behavior tree. Perfect. So from AI character, after let's say 1 second, just start running, and here we go. It starts running, everything is working fine. I have my Blackboard set, and cool, perfect. How about I don't want to run it from begin play? I just want to call it by an event. In this case, this is a editor event, calling editor. So when you make a custom event like this, you can tick calling editor, and this will be implemented only in editor. You don't have it in packaging or things like that, as far as I know. So I want to just, it's very, very useful for debugging. You may call this, you may call this even not call in editor and call it from different objects or inside, you know, by other procedures. Anyway, let's just talk. Let's just make it like this, compile and save. And here we go. So what is happening? I get the controller, cast it to AI controller. From AI controller, send the Blackboard key, name, and position number 2. So here I have I already set my behavior tree to be used. Let's just make it from here, like this. And then I grab the name from that keyboard, BB key, and set the position and just get it and just draw a debug box, compile and save. And if I run it, grab my character 01, set move location by target. Here we go, set move location by target. This is the event I already made, and if I click on this, this is the destination, and this guy start to moving. So this is how you activate your AI, your behavior. Okay, so let's talk about the second character. When I run it, as you see, perhaps in your sample project there is 3 points here, not 4. But as you see, it just goes through all those points, wait and go for the next one, wait and go for the next one. How that happens? So first thing first, let's talk about this object, blueprint actor object. There is nothing in this, there's no code here. There's only one public variable of the same type. So this is BP target node, and I have BP target node. Same object type, but public. That means I can use that public variable to point out to the same object. So I get rid of this one here and grab this. I point out to this one. From here I point out to, let's say, make a reference of this one, and from here I reference this one. Perfect. So this one is point out to this guy is point out to this, and this one is point out to this. When I run it, the character start moving to, let's say, the character as well has a public variable for that target node. So I can say first check this one here, and it will goes to this guy, and then second one, and then the last one. So these target nodes are quite useful to make a path. So I can grab this, duplicate it, move it here. From here, please check this one. From here, check this guy. From here, check this one, and from here check this one. Let's double check. You point out to this to this target. Next, oh no, please point out to this target, and from here point out to this target. Always check your path. Here, 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 and then here. Perfect. And I want you to move first to this object. And here we go. Goes there, wait, and then goes to the next one, next one, next one. So quite useful for prototyping. And even though I disable tick in this object, so it's totally a light object, perhaps you implement something from C++ and make it much better to use. So perfect. How about the character? Very interesting behavior. It just sounds like automatically it knows where to go. Where compared to this one, we already told him where to go, and perhaps if I run this event again, it just starts by an event like this. So two different behavior. This guy knows where to go, but this guy needs to get prompted. How that happens? So let's check this character. Inside the character there is nothing. I just have a target node, a destination. So it should happen from AI controller. Let's open the AI controller. AI controller number 2. So yep, in begin play I run behavior tree. From behavior tree I get the control pawn and figure it out if that is an AI character number 2, which is this guy here. This is my AI character number 2. So I detect my AI character. If you already know how to do interface programming, it is heavily recommended to avoid casting and use interface and grab everything from interface. I will point out to this. It's very important in AI programming. Avoid cast as much as you can. Just use interface as much as you can. So from my AI character, I grab the target node, this guy. And from there, I set my Blackboard key, which is an object. I set my knowledge to an object. And here is a method to get the Blackboard. Yes, like previous one, you can use Blackboard number 1, number 2, whatever you want. Or you can get Blackboard straight away and set value as an object. So the Blackboard key name is target object. I grab the location of it and just put a debug capsule, draw a debug capsule there. Alright, beautiful. Let's check the Blackboard though. So this is my Blackboard. Inside the Blackboard, my knowledge is basically an object. And this object is a BP target node. So when you make a Blackboard key as an object, you can define what type of object you are looking for. Very useful, very powerful. Alrighty, how about behavior tree? Everything should happen in, there is something in behavior that makes this guy to automatically find the next target, isn't it? So let's check the behavior tree. This is my behavior tree number 2, and here we go. Debugging. If you have a second monitor, just put your this behavior tree to another monitor and just check. Let me bring this guy here. This one, behavior tree, perfect, and this, awesome. Which, let me just run, choose the AI controller number 2, which is control this behavior tree, and here we go. So I have my move to, and then I have wait. And then it sounds like this guy get ticked suddenly, and that is where the magic is happening. So when you, and already as you see my target object is changing, automatically it knows where to go. So it's quite important that you can debug your behavior tree, your Blackboard variables during when you run the AI scenario with your game. So here This visual debugger is quite useful. Okay, perfect. So what is going on here? As I mentioned, you have number of tasks which you can choose to run with your AI, like play sound, like wait, which I use here, which I move to use a Blackboard key to move to that object, and other things, play animation, and at the same time you can make your own tasks, which these guys is basically the task I already made. This is a custom task which I make for this AI, and this behavior tree, and inside this basically custom task I will point out how to make it. Just be patient. If you double click, you will go to you will get navigated to an AI task. Everything begins with an event receive execute and end with finish execute. How these things comes up, just be patient, just pay attention to the pattern. Pattern is important. And this finish execute is finished with a success ticked on. So for now, every time you have a sequence, every time you have a custom task, by any chance if you use receive execute, you need to finish it with success ticked. I will back to this part soon. It's very important to understand it, but just for now keep in mind a sequence need to have a finish execution with success ticked. If I don't tick that, compile and save. Let's back to this guy here, run it and see what happened. Goes there and sounds like without any waiting it just switched the path. So this is a different behavior compared to the first one. So what is happening? Basically it moves to and never goes to wait. So every time you have a sequence, if you don't finish your sequence with success, basically it doesn't go for the next task or task. So I have another task here. It never goes through those ones. It will return to the first task. So interesting. What is this receive execute and finish execute? Before I go through what are they, let's see what we have here. Whatever you need to do need to be happen between event receive execute and event finish execute. Between these two you can put your task, your AI task, whatever you want the AI do, you can put your code for that between these two. What I did, I have a public Blackboard key, which is this guy here. How to make it? Variable bb key underscore 02, for example. Data type Blackboard key selector. That's it. And I make it public. So I use a bb key, Blackboard public variable, grab it as an object, cast it to target node. If that is a target node, I grab the next node and assign my Blackboard key to that again. It was an object, now it is a non-new object, same type. And I just draw the debug out of that coordination and finish my execute. So if I go to my behavior tree, click on this task, you will see the bb key public variable is here, and I set it to my target object, and that target object is part of my knowledge. So from that knowledge, it grab that knowledge key as an object, figure it out, is that a target node, grab the next one from that target node. Keep in mind, this is my target node, browse, this is target node, and this is the next node. So I already have that there. Each of them is pointing out to the next one. I grab the next one, assign my Blackboard key to the next one, and pass success, and it does the job. So how you make, very interesting, how to make a custom task. When you go to behavior tree, on top you have new task. These are the tasks which are already made. You have BT task, behavior tree task, blueprint base. When you click on it, it will ask you where do you'd like to put that object. You choose where you like to put it. Type BTT, behavior tree task prefix, and then name your task and save it. After that, you can choose your task from the list. It comes up here. And then when you make your task, you don't have anything here. It's totally empty. Compile and save. You have a function, a couple of functions, or let's say events, you can override. One of them is event receive execute. There are others, receive abort, abort AI, tick, and tick AI, or execute AI. When you receive and execute, as I mentioned before, you need to finish, execute with success if you use a sequence. For now, I will go through that part soon. What is that means success? Why success need to be there? When it need to be false? Things like that. And here we go. I want to do this between this begin and finish execute of a receive execute event. So that's how you need to make your task. You have question, okay, what others are doing. Just be patient. Let me go through the topic. And okay, so keep in mind, by any chance, if this guy return false, it means you didn't finish execute. So it's import. Okay, so you don't have this one here. I just put that there to explain. Imagine you have an if condition here, and this if condition is always true. So it just pass and everything is happening. If this if condition is false, it will go through this part here. It means it never run finish execute, isn't it? If I compile and save and run, as you see, it never goes for the next task. It always stays there and never switch to anything else. So be very, very careful when you use event begin, receive execute. You need to finish it. If you are in a sequence, it's better to finish it with the success because it can move to the next task. If you don't finish it with success, it will jump to the first task. If you don't finish it at all, like this situation, it never switches to anywhere else. So in your example, this node is not exists like this. Just keep in mind that was an example how that can be, that scenario can have some problems. Alrighty, perfect. Now, there's one thing I like to point out. In behavior tree, one of the systems, one of the tools, tasks, one of the tasks that are implemented by the Unreal Engine as a tool for you is move to. Also, you have wait and other tasks here. These are default tasks. Move to, use a Blackboard key, can be a vector, can be an object, to move to a location in your scene. I need you to click on the scene, press P on keyboard, and you will find something like green coming around your area and covers everywhere, most of the location of the map. So this this object who is responsible for making this green area is called nav mesh bounds volume. Nav mesh bounds volume is responsible to calculate and process the area of your map which AI character can move to. So if I remove my nav mesh totally like this, Nothing is green and no one is moving. All right. So be very, very careful before you use any move to in your behavior tree. You must have a nav mesh volume, bounds volume implemented in your scene. How you find it? Here, type nav mesh bound volume. Here we go, bounds volume, which is this guy here. Drag and drop it to the scene, and you can just resize it in a way you like. How nav mesh volume is working is out of the scope of this video, but just keep in mind nav mesh, when you drag and drop the nav mesh volume, you have a recast nav mesh default, which is pretty useful for debugging the nav mesh. It gives you extra data how nav mesh is working, can put some graphical area over it, put labels of how the AI is working, things like that. So this one is pretty useful. Anyway, let me press P again and remove the nav mesh. And now it's time to go for the next part, which is this character. Righty. So let's talk about the third character, which is character number 3. Let me run and see what we have. Sounds like it suddenly changed color from yellow to black, and it saves that color everywhere on each action. So that's a different behavior. Yes, it's similar to this guy, which moving to different location, but the change color here implements a new behavior. This is different from number 2 and number 1, and also number 3. So what is the secret? So first thing first, let's check the knowledge. What knowledge it has? It has a destination object, and that destination object is basically an actor. Alright, interesting. So what else? Let's check the behavior tree. Close these behavior trees here. All of them. Number 1, behavior tree number 3. Alright, that is exactly the same of behavior tree number 2. Same move to, same find other nodes, same weight, but sounds like it has a new component, or let's say module, in green color. What is it? This is known as AI service. So when you run your behavior tree, you can run services with your behavior tree. How you add the service? Right click, go to the service, and by default you have default focus and run in environment query system service, EQS for short. And there are other three which I already made. So you can have a service in different nodes, different tasks, sorry. You can have multiple service to different tasks. You can click a service and press delete on your keyboard to get rid of them. Or even you can add a service to your composite node, to the sequence, like this. Alright, I will point out how to make a service. Just pay attention to the pattern, how the service is working. Let me bring it light control to wait and move to task. Perfect. For the first one, I have a color value. I changed that to red. For the weight one, I changed the color value to be green. Perfect. Right, the red, yeah, perfect. And if I run it, let's grab this. I believe you have a second monitor already on. Please put your behavior tree on second monitor and monitor what is going on. Much easier. So here we go. So when I run it, don't forget to change this one to AI controller number 3 one more time. So interesting. Every time it is moving, it changed to red because this service is running. And when it's waiting, it goes to green because this wait service is running. Red and green. Again, red and green. And this find other node is exactly the same task as I run in behavior tree number 2. Find other node. Grab an AI Blackboard key. In my example, it grabbed the Blackboard key of destination object. Do the same and all right. So what are services? Services are, if I double click on this service, services are separate process, separate programs which get run, get executed when you reach to a specific AI task or AI composite. They are very, very useful. For example, your AI character need to connect to the internet, grab the weather situation, date and time, things like that, and broadcast and show that over that task to the inside the game. When you run this task, you connect to the internet, grab those data, and show off. Or it can run animation or extra functionality with your AI character. Or it can connect somewhere else in the game, some other objects, and activate those objects. Do something with those objects. Inside your service, like AI task, you have number of functions, or let's say events, which you can use to override. Activate AI, deactivation AI, search start, and tick and tick AI. For this task, I mean light control, I'm using receive activation. Every time this service get activated, this task will get executed. If I run it and I choose the spawned object, which is this one here, one more time, I choose the spawn object, perhaps this one, and now let me just grab this light control. Number 1, the service we have. Okay, here we go. So where is the character? No, doesn't run. Run again. Here we go. Beautiful. So as you see, this service straight away gets run every time it reaches to any of these point and over running, over moving as well. So very interesting. So how that service is working, basically I grab my color, I grab the owner actor, cast it to AI controller tree. The owner of this service is AI controller. All right, from AI controller, I grab the control pawn, figure it out if that is a character number 3, which is this character, this guy here, this one. Okay, and then on that character, I run an event and send the color. That event basically grab the mesh, grab the material, make a dynamic material instance out of it, and then set a vector parameter of that vector material, which is color, to the value I pass from that event. Just keep in mind that material is this one here, and the color is basically, this is the parameter on material instance. Be very careful, be organized with your AI implementation. Put all AI objects in one folder. Don't make it messy. Believe me, that is important. Behavior tree, Blackboard, AI controllers, AI task, decorators, and services. It's heavily recommended to be in one place. Perhaps you put characters different locations. Depends on your artists and designers how they decide. But it's important that AI tools and components be at the same location. Anyway, perfect. And please use interface. Do not cast. So from the owner actor, which is AI controller, perhaps run an interface, grab what you want from the pawn, from the controlled pawn, from the character. Don't cast, just run interface and grab what you want or execute what you want. Interface is out of scope of this program, but this is just basic implementation to show you how what is the pattern and how things are working. Beautiful. So let's get rid of these services and add a new service to the composite node. So I have three composite nodes: sequence, selector, and simple parallel. I am using sequence past examples. You can add a service to this composite node. So I choose light control special. All right. And if I click on it, I have a default color and I have a randomized Boolean public variable to tick. And I tick it. So if I run it, let's see what happens. Very, very interesting behavior. Sounds like every time it goes to each node, it automatically resets to a random color. How that is possible? Yes, obvious there is a service who do that for us, but how that works? So let me just grab the behavior tree, double click, and here we go. If I use a receive activation override function, nothing is happening. Compile and save. As you see, nothing is happening. Sounds like it doesn't totally get executed at all. Okay? But if I use receive search start, it works exactly as it was before. This guy here, change the color, and this guy here, change the color, and this guy here, change the color. Perfect. If I use receive tick AI, and from this event I already have control pawn, so I just need to just connect this one here. I don't need, let me just bring this guy there, this guy, this guy. I don't need to cast to a controller, it already gives me the control pawn, which is this guy here. So I just cast it to character tree and call that change color, grab a Boolean selector. If this false, send the default color. If this is true, randomize the color. Perfect. How that works. And now you have, oops, one more time, run. And now we have a very interesting behavior. It sounds like continuously on a specific period, it just changed the color. So as you see, there are three different behaviors which are happening by choosing different override functions here. I'm not going through each one exactly. Please check the Epic Games documentation. Also for AI tasks, you already have same different functions. Here we go. If I try to override the AI task, I have this one. I already point out to these ones. I already point out to receive execute and finish execute. So just check how each of them are working. It's out of the scope of this program, but believe me, the pattern is the same. Some of them are sensitive to some specific node. For example, if you have a composite node, you need to use event receive search start. So interesting, very, very interesting and useful AI module or component, let's say, which is AI service. We add this service again for the light control. For the light control, when it's moved to, change it to green, 0, and when it is waiting, oops, here we go, change it to red. and here we go. It moves, it is green, and when it reached to that position it became red. For the services, you don't need to finish your execute or something like you do with AI task. But for AI task, every time you have a sequence, you need to finish your execute in order to pass to next task, and also doesn't stop in that, in that position. If you don't have finish execute, it never goes for the next one. Anyway, so at this point we learn how to use sequence. Everything every behavior we implement here are using the sequence node. Sequence node will repeat AI task from left to right. You can see the number of tasks which is happening. Here it first run the service, then it start move to, then it goes number 3, switch the target, then it will change the color, and then we'll wait. Perfect. Keep in mind, for any service you already have couple of properties. Let me just get rid of these two. Back to the sequence, add my service of control special, make it random. So what it was changing, it continuously changed the color, as you see with the period. If I back to my behavior tree and change that interval to 0.1 and run it, that changing color will have a faster period. Why that happened? Because if I open my service, this is happening on receive tick AI, and if you check the service, this is interval tick of AI every 0.1 seconds. So this type of control, like for example, if you have a wait on AI task, you can change the wait time. For the service, you can change these parameter. It depends on this parameter, you can run your events and add complexities to your behavior. Be very, very careful. You have AI service running. I have AI service to change the light color. I have AI service to change the light color here. Perfect. You don't need to run any extra code with your character. As you see inside the character, I just have one event called from AI controller, called from behavior tree to change the color. You can implement a personal, function, detect how the character is moving, depends on the character movement, change the color. You can do that here. But you can run an AI service and save a lot of time and make things more accurate. When it is moved to, perhaps the animation change. When it is waiting, perhaps a different animation get played. You don't need to put code here inside the AI character to run that animation. You just can add those code inside an AI service and run it from that service. So services are quite useful and can save a lot of time of programming and can synchronize exactly what you need to be done based on that behavior on a specific task or perhaps a specific time. Beautiful. Okay, so let's talk about the last character, which is this guy here. So I need you to open the behavior tree number 4. Behavior tree. Okay, so let's talk about the character number 4, AI character number 4. I need you to open the behavior tree number 4, grab the root, connect the root to the selector node, composite node here. Previously we talked about sequence and we go through how the sequence is working. Now it's time to talk about the selector. So selector, sequence, and simple parallel are at the moment the composites available through the engine for Behavior Tree and Blackboard. At the moment, I mean end of 2024. Perhaps in the future you have more composites here, who knows, or you may add a plugin to add new composite, but by default you can use these composites to to make your behavior, to implement, to develop the behavior with Behavior Tree and Blackboard. So let's see how that works. I have an AI task, Behavior Tree task. If I double click, I have a public variable result, I have a public variable action name. I print out that action and send success through that result value. It can be true or it can be false. So if I choose a sequence here and connect the sequence to each of these nodes, first one is enemy fire, result success. Second one, enemy hide, result success. Third one, enemy heal, result success. And the last one, enemy chase, result success. Perfect. So if I run it, let's go to the output, clear, back to the task. I just copy this action forward here, put in the search log, so it just shows the messages who have action as a part of that message. Very, very useful for monitoring your actions. And if I run it, I have fire, hide, heal, chase. Fire, hide, heal, chase. Go to the behavior tree, choose your area control number 4, and that's how it works. Goes there, 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 there. Perfect. I can even put some weight between these tasks to make it like time-based. Clear log, fire, wait, and then hide, wait, and then heal, wait, and then chase, wait. Here we go, wait, wait, and then wait, like this. Perfect. That's how a sequence is working. You need to send success to your task for the sequence to pass to the next one, and you need to finish the execute if you use receive execute. All right, now let's check a selector. I select this one, and then this one, and this one, and also this one. All of them are sending result true. All right, perfect. So let's run it, and it works fine. Well, it works very strange actually. It just ran the first one. All right, let's stop it, grab the second one, grab the first one, change result to false, so I will send false to success here, and then run again. Clear log. So it just say hide, fire, fire, hide, fire, hide, and sounds like just switch between these two. That's it. There's nothing else happening. It doesn't pass through the next one. Even though I sent success here, sounds like the selector doesn't like to move to the next one. All right, let's put a weight between these two. And the result is quite strange. If I clear the log, it run the fire and doesn't move to anything else. It just switch between fire and this weight. And the reason behind that is this wait task will send a success as true to the selector node, and that's why it doesn't go for the next one. Just go to the first one and repeat the first one again. So it's very strange behavior. You may find, okay, I can use sequence for everything I want. I can make it with sequence. Why I need this selector node? Selector nodes are designed to give you control over each part of your behavior. They are much more advanced than sequence node. Sequence node is a very simple composite node. It's run everything from left to right and repeat. But when you have a selector, you can select what you like to do. Okay, so to understand selectors, to use selectors, you need to use something called decorator. Decorator and selectors are work with each other pretty well, and you can implement complexities within your AI character by using a decorator with a selector. From decorator, you can run different composite tasks like sequence in this example. You may surprise, okay, what is going on? We have a selector and then we have sequence. What is that? Keep in mind, from each AI composite, you can run another composite. And from that composite, you can run another composite again. Perhaps you run two sequences from here, and you run another selector from here. So you can make a complex behavior by using composites. Also, you can use simple parallel. You can use a simple parallel here as well. All right. Now, when we talk about a decorator, oops, here we go. When we talk about a decorator, how to implement decorator, just be patient, I will go through that soon. When we talk about a decorator, as its name shows, the decorator is responsible to decorate the behavior. Depends on something, you may like to run this sequence. Depends on something else, you may like to run this sequence. Okay? So how the decorator are working? If you right click on your composite or any task, you will have something called add decorator. There are default decorators, which is implemented by the engine, these guys here. And this BTD, behavior tree decorator alarm check, is something I made, which I will point out how to. But you have a very, very good collection of decorators. You can have a loop, you can have a blackboard key, you can have a force success, you can have time limit. The very simple one is blackboard decorator. To understand how the decorator is working, understanding blackboard decorator is a must. So how you do that? You right click on your composite node, go to the add decorator and add blackboard decorator. It comes up at the beginning of your composite text, like what I did here. From blackboard decorator, you can choose the blackboard key. In this case, bring this guy here. In this case, I choose alarm state, and I say if it was equal to default. So what is this alarm state? Let's back to the blackboard. This is part of my knowledge. Alarm state is basically an enum. That enum has a value of active, deactive, and default. All right. And depends on the value of that decorator, that enum, I will switch between behaviors. I have default, I have active, and I have a deactive. Sorry, that should be deactive. Here we go. So here I have a sequence for active. Here I have a sequence for deactivated. And here I have a sequence for default. Perhaps when it gets deactivated, the enemy units start to play an alarm, making noise, ask other enemy units to just comes up, blah blah. And when it is active, perhaps the enemy unit just deactivate it and switch it to default. That is what before, something like that. So let's run and see what is happening. So the players start to moving between different tasks. Every time I go for the alarm trigger, it will stop. And if I move out of alarm trigger, it will back to his own situation. It's back to the alarm and stop again. And then back to normal situation, it's just back to his own work. Let's track the behavior tree and see how things are working. Grab this guy here, this one, and back to the map, stop it, and run it again. So I have a selector. This selector can select different situation. I have a Blackboard key, and the Blackboard key is already set to default. Because my decorator, which is a Blackboard base condition, is set to default, bring it down, this one, top. Because my key value for this decorator is set to default, alarm state is basically Blackboard key is set to default, it will run this one here. Now, if I move to the trigger, see the Blackboard key change here. It is default, it became active. And now the decorator here is sending false. So the selector don't run this and pass to the next one. And the next one is setting true. It is active, it is active. So it tried to run a sequence here, which is nothing. So no behavior is running here, and the AI just stops. Let's change this route to the next one here. Perfect. So the first one, Blackboard condition, is default. Alarm state is default. The second one, alarm state is active, and the last one, alarm state is deactivated. So if I run this, like previous, it goes to a sequence, it moves to this destination object and swap the destination, like the other AI characters. If I move to the alarm, it will run this sequence, and that sequence has a task, and that task is basically move to alarm position, which is this position here. If I move out of it, see the Blackboard key alarm state became default, and it will switch to the previous one, which is this one here. This is how you can control a selector which select the behavior of your AI character. In this case, I have two sequences of different behavior which I can select by using a Blackboard decorator and switch between these two. So it's quite useful how to manage your AI behavior, how to decorate it, and reach to complex behaviors. Perfect. There is one problem here. I will point out how to make decorators soon, just be patient. If I imagine this character is here, it's moving between these two. If I move to the trigger and straight away back, it sounds like it can't detect me. It need to go to one of those destinations, and then it detect, hey, there is something activated, and then it return to visit the alarm trigger. And if I move out, it will move to its own work job. What if I want everything happen immediately? So straight away, every time I go here, this AI character just immediately jump to the alarm trigger. How I can do that? So there is an option with your decorator, and that is basically observe aborts. That observe abort property can change to self, lower priority, and both. I'm talking about, I will point out to self, but please go ahead and check resources about these two, see how those are working. If I grab this guy here, put that here, I just have two different behavior if the alarm is default or if it is active. But both of them have observe abort on set for self. this one, and this one. And as you see, when I click on the decorator, not the AI task, AI composite decorator, I have a change of color of these two blocks. So let's see how the behavior is changed. This guy here, grab it here, grab my game and play. Perfect. So every time I move to the alarm, immediately the AI character moves to the alarm set. Even though if it is in the middle of its way, it will return. We don't have that behavior for the previous one. If I move the root, grab it to this, point out to the selector of previous behavior. If I move here, it will chasing me. And when it goes out, if I move again, it doesn't detect unless it goes to one of those. So it's like a little bit buggy or delayed. Here we go. Need to meet that target, then it will detect. See, it doesn't go immediately to me, doesn't run to me immediately. But if I have that decorator observe abort option set to self, it will respond immediately to what is going on, like here, like here, back here, like here again, moving out again. Doesn't matter where it goes, what process is doing, immediately back to me. And so you may find, okay, it's a little bit delay. How we can fix that delay though? Every decorator has a couple of options here. You can check. At the same time, you can check the AI composite, apply decorator scope. If I check this one, and I check this one here, I have like this. Straight away it will return. Straight away it will return. Not really, actually. So now let's check the last part here, which is this one. Here I'm using a custom decorator. Previously I used the system decorator, but it is the engine default decorators, which are these ones here. But for that behavior, I just use a BTD, stands for Behavior Tree Decorator Alarm Check. How to make a decorator? You just go on top, new decorator, this one, BT decorator blueprint base, and you click on it. It asks you where you want to save it. Just BTD, call it BTD Behavior Tree Decorator underscore the name you want, and you have the decorator, custom decorator implemented. Same like service, same like a new AI task. So how that works? If I double click on my decorator, same pattern. You have number of functions to override, number of events to override. What I use is perform condition check, grab the blackboard, figure it out alarm states. If alarm states are equal to what I have, then return yes or no, and that is basically the success, like the success for the decorator. If that is true, the selector will always run this part. If that is false, the selector doesn't run anything, will switch to the next one and will check if that is true or not. So basically this is like an if condition in programming. If it is true, do the job. If it is not true, go for the next one. If that is true, do the job. If it's not true, go for the next one. And each of these decorators have an alarm state, public variable. In this case, I set it to default. In this case, I set it to active. And in this one, I set it to deactive. Here we go. It is a enum, same data type like the enum I made, same data type like I use in my Blackboard. Let me bring up here. Here we go. And that's how you make a custom decorator. Using decorator are extremely useful. You can make complex AI behaviors. You can switch on and off different behavior. For example, assume I have a couple of behaviors here. Depends on this decorator, I can go through a sequence of another selector with 3 different states. So it is possible that you can put your AI like this, and that is a complex behavior. Different task, different decorator you can implement, or you can use just default task or default decorators. You can run services on selector like this. Every time it is deactivated, run this service, perhaps running some sounds, you know, the player just deactivate an alarm, enemy units just start, hey, something happened, blah blah, you know. So it's quite beautiful how to use Behavior Tree and Blackboard for your AI implementation. Now it's time to talk about the last part. Let's say, composite, AI composite. So far we know sequence, we know selector. Now let's talk about simple parallel. Let's run and monitor, see what is happening. Grab this one, clear, grab this action, clear, okay. And I have something comes up, counter 4, 5, 6, 7. Interesting. What is it? And the rest of behavior is exactly the same. Every time I'm in trigger, just chasing the trigger, visit there, and then it can return again, same. But I have that counter, and I have an alarm triggered. Alarm is default. So what is going on here? Let me open the behavior tree and check. So a simple parallel task is always running one task. All right, you can run service over that task or different couple of services with that task, but keep in mind this is always running. And the next part of it can run a composite. In this case, my composite is basically run a selector with decorators related to the alarm check. That's exactly what I did for this one here. So the simple parallel gives you opportunity to run one AI task always. Perhaps this task you connect to the internet, grab a couple of data and involve those data with your game, or you use a third-party application data like another AI generator and use those data within your AI character when it runs the tasks. Or you simply want to make a report out of game. It is quite useful to make scientific applications when you want something always ticking, always running, and it run a couple of services for you. So in this case, my service is receive activation. I have a counter. I increment that counter and print out. So when I run it, as you see, always this counter is get incremented. How that works? Every time this task is ticking, that counter get incremented. So if I go to this task and say after 0.1 just run this task. So this is first is run the service, then run the task. Service, task, service, task. So I have like this. Wait 0.1 and run run the service, wait point one, run the service again, wait point one, run the service again, 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 and again. And that is comes out of my receive activation. You have other events here you may like to choose. So it's quite useful, quite powerful. Keep in mind you can run only task here. You can't run anything else, even though you can run a service. You need to have a task and then run your service. You can run simple tasks like this, print messages, and if I run it, it just works exactly like receive execution. Every time it gets executed, it runs that task. And on the other side, you can have composite and normal programming AI, even you have from the root, like you can choose the composite and you do the job. Even though from here you can have another simple paragraph, and from here you can go through your task and perhaps run another task here. Let me just grab this guy here and grab this guy here. Change the wait time to 0.22 seconds. Compile, save, and run. And check the result. So, as you see on each two, it just run. Just refresh this. Let's just program this part a little bit more. I add another variable. I message, make it a string, public string please. And then here I involve that with my character like this. Compile and save. Back to behavior tree. For this print message a service, I have my message. I just say message here. And for the print message, which is a task, I don't have anything. Just keep in mind this is task. This is a service. And then when I run it, clear log, back here. And here we go. As you see, every 2 seconds I have that service running, and the rest is just my task. The other task gets running. So it's quite useful and quite powerful node. Perhaps in the future we have more AI composite, who knows? But yeah, perfect. So that was the implementation of AI using Behavior Tree and Blackboard. There are a couple of things I'd like to mention here. First of all is basically the size of your characters and the speed of your AI characters. When I run this, as you see, this character runs very fast and the size of it is very small. But the other one is huge. And if I try to run it, try to move it, where is that event to? I implement that event somewhere. Here we go. If I try to move, as you see, it moves very, very slow and it's a huge. So it feels different than this guy here. And the secret behind that is number one, the size of the characters. This one's size is a little bit larger on Z scale, and this one is totally smaller. At the same time, the characters have different speed. So this character movement speed is the key. It's a very, very useful component you can use for your AI. If I type max speed, for this one I just choose 240, and for the character number 4 I choose that for max speed 800, which is this one here. So it's run faster. I didn't do any extra code. I just use character movement properties to implement a different feeling of the AI in my scene. So be wise of using system resources and system tools like character movement components. And that was basically this part here. So if you back to your behavior tree number 4, grab the root, move the root to the first implementation and connect that here, and then run. The behavior is very interesting. Every time I go to alarm trigger, the AI character is chasing me, and then when it meets me, it will return to his own job. Again, if I go to the alarm trigger, the AI character chasing me, and then back to his own job. I'm not going through what this task is doing. This is your homework. Keep in mind, when you get hired, you may, your future, just bring this guy here. When you get hired, your future programming team leader or manager may ask you to go through previous AI code, check how that is working, and perhaps implement an upgrade into it. So this is a good opportunity. Take it as a practice or as a homework. Check this task, see how that works, and perhaps upgrade it. I didn't implement the whole scenario of this example with our with the sample project. Perhaps implement this scenario. There are similarities. For example, this guy need to meet this kid, and then together they can go for the exit. That is similar kind of to what I have here. Every time I get the alarm trigger, this guy need to meet me, and then he can back to this job, whatever it has. How the alarm is working, bros. This guy, every time I have a collision, I set an alarm boolean variable in game mode from my AI character number 4. Untick, I grab the game mode, figure it out the alarm, set my lights, and then call AI character, AI controller. From AI controller, I run an event. From that event, I send the alarm state as enum, and from there, I just upgrade my knowledge, which is a Blackboard key. So just keep practice. Perhaps use this sample project as a prototype. I use the third-person character mannequin and animation for this sample project, just in order to make it very light. I mean, as size, it's just just 33 megabytes. So it's quite optimized for making prototypes. Thank you very much for your attention, and please send message through through the comments if you have any question, if you have any problem, and thank you.